Okay, hello. Hiya. Good evening. Good to see you. Okay, let me show this screen here. All right, so I don't know if it helps or not, but during this week, by accident, I turned on something I didn't even know that PowerPoint had this feature of showing subtitles. I don't know if it helps or not, but I'll leave it on. Okay, so we're recording this for other people to look at that aren't here, or anybody could go back to um, look at it at any time. Uh, so this segment here in our course, we are talking all about energy, metabolism, body composition, and weight management, and the vitamins. Uh, so there's a good amount of uh, material there to go over to learn. Some of it hopefully is you've seen before in some other courses or your normal reading and being aware of things. And I have a set of questions to give you a flavor of at least for the multiple choice, which are majority of the tests. How much in depth, how much detail? I'm not going to ask the intermediates in the Krebs cycle. We leave that to if you're taking or go on to taking a more in-depth biochemistry course. But there is some detail there. The vitamins, there's 13 of them to know a little bit about each of them. We have the 9 water soluble and 4 fat soluble. And I'll give you some ideas also, additional ideas to remind you how how do we learn this stuff so that we can if we had a short answer to write a few sentences explaining something or making a connection between um, or among a few ideas. So exam 3 coming up next week. Um, let's see, what do we have from the 3rd to the 5th? Open so that whenever is convenient to find a quiet place and to sit down for. And again, you'll have the same amount of time. Most people are not using all that time, 100 minutes. It's a lot, but if you can, it's a good idea to make sure that you've looked over and made sure that you've answered everything and be sure about as much as possible. It can't hurt to review what you've done. You know, look at the short answer questions. Have you said enough? Maybe another sentence or clarifying something. Better to write more as long as it's reasonable and addresses the question. To take the time to to uh, to make sure that you're done. Don't rush through it. Mind tap chapter exercises are important. They're you should be getting most all of those points because you have the opportunity to repeat various things, and it's really a matter of taking the time to get through those little short readings and the diet and wellness activity and reflecting on things. It kind of anchors you, as you probably had in other courses, to take some time to let this material to see it in different ways and not just read a textbook and try to absorb everything straight from reading. Um, Making connections using graphic organizers in addition is, if you're used to that, does make a difference. It helps a lot. Everybody has their own way of learning things. It's been shown that if you really engage yourself in material, not be distracted, that's real study, real work, as opposed to just trying to do two or three other things at the same time. It really is much more worth your time to focus in on one thing at a time. Um, okay, uh, so this all about um, energy, weight, weight management, body composition, and vitamins. And I don't know if everybody knew, but this month, March is, among other, I think it's Women's History Month, but it's also National Nutrition Month. I don't know if anybody knew that, but the theme this year was Beyond the Plate, meaning um, there's other things to think about in terms of our food supply and nutrition. It's yeah, getting the balanced eating pattern, but also thinking about uh, food waste. Um, where does our food supply come from? Local supplies, less travel across the world or the country is better for the environment. That's the piece beyond the plate. And we all should be thinking about that too. We do live in a society, a country, a globe, and we should also give the proper thought to that. Okay. Uh, colors. Colors are important on a plate. That's that's what I have there. That's supposed to be, and it is kind of blackened salmon with rice and carrots um, and corn. So it's carotenoids and other vegetables there, good protein, and rice being the starch. These study guides, at first they seem overwhelming. They're a bit long, but these are in your additional resources. Uh, they are good to look at, maybe not just once, but if you have the ability to have them printed out, it's a good thing to annotate and um, highlight the way that you might help you, circle, because there's really important key words there, phrases, and um, I may I think I will post because someone asked me, can you um, highlight the most important things on these kind of long chapter outlines reviews, and something that looks like this, maybe when you look at it a second or third time, the words jump out, the important words that um, so I'll post these also for all the chapters. We do have 5 chapters. This is more than the previous 2 exams. Um, the energy metabolism and body composition are kind of linked together. Should have seen that. And then the middle one, weight management and health, is more applied, and also you should be seeing that many of what we've been learning and talking about is um, continually coming together. But in these the energy, maybe there's some new terms, so it's really important to have a way to think about them and think about their meaning, like anabolism, catabolism, ATP. So these are important aspects to know the difference between the energy um, and we'll go through a little bit of that and have some questions here, multiple choice questions. You'll see the differences in the anaerobic energy cycle, and that's the glycolysis, that's anaerobic, and then the aerobic portion of energy metabolism, and that's the TCA cycle, also known as the Krebs cycle, also known as the citric acid cycle. So there's three names there. And this is where you see the three energy yielding nutrients. That's carbohydrate, fat, and protein. And then the importance of these helpers in energy metabolism, enzymes, coenzymes, and cofactors. Enzymes, those we've spoken about when we talked about each of the digestion, absorption, and metabolism of each of the macronutrients. And we learned in these the vitamin chapters that they serve as to almost assist their cofactors, and sometimes they're called coenzymes. Also, they're so important in helping out the cycles in getting energy. Chapter 8's outline, and here's how I'll go from that and then a little more of it, and then I highlighted really important terms that maybe help us see through the other words that upon second, third, and more time, we don't need those other words in there, and the important stuff jumps out at us. Things like body weight and body composition, and that leads into this: how do we assess body composition? And that's seen as more important than straight body weight. Where is the weight that we have on our body? Is it muscle? Is it in other words, lean mass, or is there adipose? And where is that fat tissue? That's important in health outcomes. And that's not as much BMI, but some of the other measurements of body composition really are more instructive in our health of our body composition. BMI, that's a very simple, quick indication. It's a gross kind of look at, because it's only measuring height and mass. Doesn't tell us anything about where that weight is. Is it all muscle? Weightlifters and all, you wouldn't call them necessarily overweight or obese, but if we go just by body mass index, BMI, many of them would have certainly overweight and obese numbers. It's waist circumference is also helpful. More and more in physician's office, they don't only calculate this BMI, but they do this waist circumference measurement. Then there's other more detailed, not as common measurements of body composition, and that's some of those that we've seen in the chapter, where they submerge a person and get displacement, or also a DEXA scan, much more detailed of our makeup of lean and adipose, and even where our bone mass is. This bomb calorimeter, I highlight that because that might be one of the multiple choice questions. Bomb calorimeter is used to get the calories from a given food. Now, food, of course, we know, not just any kind of food. It's never strictly only carbohydrate or only fat or only protein. There are always some mix of those. Bomb calorimeter is this device that actually ignites, and as a food is burning inside this sealed device, the amount of heat that is evolved translates into the kcals that that food item has. And this was done um, over the course of many years, and there's compiled data, and that's where we get from our databases. If we plug in um, sour cream or banana or salmon, and we get these rough calories per gram. They come from these kinds of data from bomb calorimetry, bomb calorimeters. The weight loss chapter, that was the lecture was by Dr. Amir, um, who is a diabetes educator, a pharmacologist. So um, she spoke a nice lecture on that material that's in our textbook in chapter 9. And she spoke a little bit more about, and it's not going to be on the exam, but some of the new medications that are now being prescribed to those diabetes and obesity. Some of the newer drugs. It's a really new cutting edge kind of development. Some very good things happening for uh, diabetes and obesity. Again, I'll post how I would highlight, or how I highlight and learn things that are in chapters. So I'll post those a bit later. Certainly they'll be posted by tomorrow. Again, and these are posted already, but not with the highlighted version. I'll put those up also in additional resources on Blackboard. And the vitamins, we have the fat soluble vitamins A, D, E, and K. And so as you try to make connections, think about, okay, fat soluble, they must be um, in the way that we absorb them and move them around. They can't just go right out into the bloodstream. They're fat soluble, so they have carriers. They're not floating around without being assisted by proteins or carrier proteins. And when they are deposited in places like the liver, um, they're there until the signals are such that they need to be go to other tissues in the body. And as you see vitamins like A, you should think of, okay, that's beta carotene. Okay, I know that's vision related. I know it has some skin roles in good skin. And it's also has this antioxidant um, character also. When you think of D, first thing that should come to mind, okay, I know that's vitamin, the vitamin related to bone. And it's also the only vitamin that is seen as a hormone. Um, so hormone acts in is formed somewhere and then goes somewhere else to act, to do its role. Vitamin D also special because it a lot of it is from sunshine, sunshine on our skin, turning a precursor uh, that's cholesterol-like, turning it into vitamin D in a couple of a couple of places needs to be hydroxylated, but it's mainly, in fact, a lot of us get a good part of our vitamin D from sunshine. It's also fortified, um, added to products like milk and other things, so that we can get a decent amount in our in a good eating pattern. Um, Vitamin E, should think about that. Okay, that's often in said to be in fish and in grain. Vitamin E, that's also known as alpha tocopherol, um, and that is serves as an antioxidant. So it serves to scavenge radicals. Radicals meaning things that can be reactive, could cause problems in tissues. It could be initiate cancers or other uh, type things. So vitamin E, antioxidant, and vitamin K. K you should think of clotting. So it has a role in blood clotting. Those several steps in vitamin K important. In that, vitamin K, very interestingly, is the first injection that a newborn gets is vitamin K. Um, that's the protocol, because a newborn doesn't have sufficient or doesn't have vitamin K, and it's just important to have a certain amount in case there needs to be initiation of clotting in a newborn. Okay. Okay. Also, remember these are also in the additional resources. It's under Whitney chapter study um, um, study guides, I guess, also a study IT. It's those are important to go through also. They're the colored pages, another nice review of the things that are in the chapter with some questions, but also some key terms that you see for energy. Glucose breaking down initially by glycolysis. Glucose being 6 carbons breaks down to 2 pyruvates, and so on. We see that here with a hamburger that has a certain amount of protein, has carbohydrate, and has fat. And here's the various pathways, abbreviated pathways of how we get energy from that burger. And transformations. The most common transformation is right here down the middle. Carbohydrates. Uh, it's glucose. We form glucose with some digestion going on here, and glucose to pyruvate. That's the 6 carbon to the 3 carbon, and then that's all anaerobic. Not doesn't use oxygen, so we can do that even if we're low oxygen for whatever reason, if we're exercising perhaps, and become anaerobic. Then this is the critical step, the aerobic step from pyruvate to acetyl-CoA. This acetyl-CoA is a 2 carbon molecule that dumps into the TCA cycle. And the key thing here is when pyruvate goes to acetyl-CoA, is it cannot reverse. It can't go back to glucose. And but what it does, it goes into this TCA cycle and gives us a good amount of energy as it goes through electron transport, a bunch of other kind of mechanisms, and finally to ATP. That's the energy currency. ATP needs to be generated, needs to be present for any kind of further movements, anything that goes on, that needs energy. That's most all of our processes need some energy, and another byproduct is water. Now we can get energy, of course, from fat. That's our second go-to. Well, it's usually mixed, just like a combustion engine has gasoline and oil. We have carbohydrate and fat, so we get a mixture depending on what our body's used to getting using a source of energy. But the fat certainly can go to pyruvate and acetyl-CoA. These are, if you remember, fatty acids. Fatty acids go here. The backbone of fatty acid, the 3-carbon, can make pyruvate and go this way also. And then amino acids also can be used for energy, although it's not the preferred way that we want to use protein. Protein is, of course, a really important building block for so many of our structure, our enzymes, or antibodies, our cell membranes, even our bones. Use protein in that way, amino acids from protein, and proteins aren't stored. We can't get a pool of amino acids to use for energy. They are used almost immediately to build things. We get the instructions continually from our DNA and RNA to make stuff. We're always repairing, we're always making new stuff. And amino acids aren't long-lived. If they're not used, we detoxify and get rid of them. How do we do that? We detoxify them by deaminating them. Okay, it's another of the few chemistry words that we need to remember is deaminate. So that means getting rid of the amine, from amino acids, and that in effect starts to detoxify them. Because if amino acids are sitting around, staying around, they're not good to have around because they can become reactive in not a good way. So we get rid of the amine. We ultimately get rid of that amine as urea. Okay, but in certain circumstances, we can use protein and get that into the TCA cycle. That's called gluconeogenesis. That is making glucose from a non-carbohydrate source. So we always need a certain amount of glucose. Why? Because our brain and certain other tissues, nerve and red blood cells, really need glucose and can't use any other form of energy. They can't use fat. So if we're in a lacking carbohydrate over a long period of time, our body tries to make some glucose to satisfy the brain's need and red blood cells need, and it does some kind of reverse building of glucose, right? So it goes this way to have glucose for the brain. So that's part of we learned in this chapter. What about if you're in excess of these macronutrients, too much of each of them, what happens? And then if we're have a scarcity of them, if we begin to go down like a starvation path, then what happens? Well, the body needs to adapt and do something, and it tries to find, it uses up all the carbohydrate that may be stored as glycogen in the liver mostly, uses that all up, then it's going to start using whatever fat it can. But fat does not have a good way to make glucose, so if so that's where the body and mechanism starts to break down protein and start to do this gluconeogenesis with amino acids to get some glucose. So I have not looked if there's any questions or comments so far. I don't see anything in the chat, but certainly speak up if you want to stop us and ask for clarification or a question. This is just the next page um, of this. So I really um, uh, say it's very important to look at the study guides, not just the ones we spoke about initially, but these colorful ones, because they also have these kinds of questions that I probably just mentioned a bunch of these, but like here, deamination of an amino acid produces what? So what the deamination is trying to do is to break it down. So we're not making this, we're not making energy, we're doing ammonia and a keto acid. So these are important, and these have the answers at the bottom of this sheet to this page to check also. But important. These are only a few, but they are the main aspects of the chapter material. So here's this important thing that we just mentioned about the feasting. When we have excess, then we need what happens to all that macronutrient if it's stored or it's gotten rid of. And we need to remember, okay, for excess carbohydrate, yeah, we could store that as glycogen. Excess fat, yes, we could store that as fat, as adipose tissue. The protein, if it's in too much of excess, we get rid of it. We don't store. We use it. If you're bodybuilding, then there's a certain time that you want to have more than maybe another person who's not bodybuilding or trying to build mass, need more protein, and that's putting it to use. And so this is the study it for chapter 8. Again, really nicely laid out in very concise. But again, you can't just go by this. You have to have depth of learning. It's just another way to review the material here. Okay. And then chapter 9. This was a very good lecture by Dr. Amir. And here's this is a little nice diagram, discretionary kcals. So yeah, depending on how much we intake, how much we use, then that's the kind of very simplistic way to think of things, but it still has value. Energy in, energy out, energy used, and then excess would be stored or gotten rid of. So here's a sedentary person, and the energy intake to meet needs maybe is here. But the more active person has probably be more need. So you could have more discretionary kcals without without needing to store them, store the calories. And vitamins, very interesting to learn about the vitamins if you didn't have an awareness of each of these vitamins, what their roles are. Sometimes the roles of vitamins seem to overlap, or some of them do. For instance, the B vitamins, many of them involved with energy. If we look at some detailed flow charts of where vitamins are involved in energy metabolism, you see the B vitamins sprinkled all around. They are important in many of the steps. Um, and So the water solubles are in chapter 10. Those are the B vitamins. And then C. So B vitamins, include all those that you could think of: niacin, riboflavin, thiamine, um, pantothenic acid, etc. 8 of them, and vitamin C is the ninth. And then the fat solubles, the 4 of them. Oh. Well, so in general, the B vitamins serve as coenzymes. Those are small molecules. They are not destroyed in their when they're involved in mechanisms. That's what an enzyme is doing, but it's not alone. They don't do it all alone. Often they're paired with enzymes, so they partner with an enzyme in making a reaction happen. Maybe it's a reaction in the process of getting to energy, getting to um, riboflavin, for instance, does this step of flavin to FAD, and it's to do with the chemistry of the redox reaction. We don't have to know that right here, but it's involved in an important step in getting to energy. And the fat solubles, they're nicely summarized here. We mentioned a little bit about A, N, and D, how it's fortified in milk. So remember, we learned about those two words, fortified and enriched. Fortified means that this particular nutrient was not present in the food before, but we add it to have it available, to make that food more nutrient dense, to have it present. Whereas enriched means the vitamin is there. For instance, orange juice, it may be enriched with even more vitamin C. That's the difference between fortified, it wasn't there before, and enriched, we're bumping up the amount of that nutrient in the food. Okay, vitamin E. And as you're thinking about each of these vitamins, think about what's the reverse. So, okay, they have a role in something. If we're deficient in that vitamin, what could happen? Okay, so for vitamin D, well, that's bone strength might be compromised. And if we go through a lot of our life being deficient in vitamin D, and also calcium, then our bones will not be staying strong, because they're constantly being built up through our life. Even if we don't know it, bone formation and kind of deterioration is going on. If we don't have present vitamin D and calcium and phosphorus and all these things, then we're going to run into trouble later on with osteoporosis. And with children, it's called rickets. Okay, vitamin K. Vitamin K is one of the rare instances that we do have microflora that produces some vitamin K. It's if we have a healthy bacterial in our gut. Same with vitamin B12. Our gut bacteria. Make a little bit of that for us. So this is just a close-up. Um, so how is vitamin D unique among vitamins? I mentioned before, it is the only vitamin also considered a hormone. So vitamin D, very, very important in many ways. Um, it's a precursor and is cholesterol. Okay, this was the lecture. Hopefully, you listened to Dr. Amir. Um, a couple of things that she mentioned. Just want to highlight again this ABCD, um, this adip, um, adip, adiposity-based chronic disease. So this is very important in the process of toward this so-called metabolic syndrome, which starts with being overweight, not good nutrition, possibly leading to obesity, possibly leading to diabetes, and then other chronic problems like cardiovascular disease, um, and uh, and even other chronic diseases. And these are all considered weight-related diseases. Uh, these are some questions that you could it's good to think about. You can I think I have these posted somewhere also, but good as you're going through material, this word obesogenic environment. I think there is a short answer about that. Like what would you think is an obesogenic environment, and how would you modify that? So that could be a just a short answer question. So we're covering in this segment for this exam, it's the vitamins, so that it's good to have a way to to try to remember what each of these vitamins um, are involved in. What's their main role? If they have two main roles, most of them have one major one and maybe one or two other less major roles. But here we see the B vitamins right there, 8 of them, and then vitamin C, and then here are the D vitamins. Uh, so in additional resources, there's this is a believe a Word document that you can use if you want to. Um, Next few chapters we'll talk about the major and um, minor minerals as we go further. There's a bunch of them to know a little bit about each of those. Hopefully, learning these, thinking about them, you'll remember these and maybe even if you see or feel yourself perhaps exhibiting a symptom of a deficiency, although that's very difficult because, as we know, any kind of vitamin or mineral deficiency is not immediate. It's not acute. It's chronic. So over a period of time, and unless you're monitoring your eating pattern, which we tried to do a little bit with at least 3 days to recognize what we may be deficient in our normal kind of eating pattern, then then we won't recognize very easily. Yes, so Sullivan, I did mention that I'll be putting a- another version of the study guides with highlights, uh, highlighted words and phrases that are most important. Yes, not every single thing on the study guides. There's more detail there than is going to be asked of you on the test. And you'll see some of the questions that I have coming up right now is about the level of detail that that the course, and I want you to be able to answer. Okay. Um, so it's best for you to actually do this kind of thing, to fill in and not just look at another table like your textbook. It's good to for you to, in your own words, do this kind of thing. And that was the idea of this graphic organizer uh, that I posted there to to be thinking about each of the vitamins. So you're in this course. It's should be curious about something like this and be the smart one to know a little bit about the vitamins. So I mentioned about the water-soluble vitamins um, and their role in energy metabolism. That the B vitamins are all over here. So here's glycolysis. This is the anaerobic stage of energy metabolism. And down here is the aerobic. And each of these purple triangles are vitamins. Each of vitamins. So is B12. This is niacin. There's biotin. There's riboflavin. And these are different forms of the vitamins, and they're acronyms that don't worry about remembering. But the point is the B vitamins are at all stages of our energy metabolism. This side here is, as you could see, if we're using protein to try to go back to glucose in some form of carbohydrate deficiency, and we need to make glucose, we can do this kind of thing. Some amino acids can get back to pyruvate and make some glucose so that our brain satisfy our brain, and when we're deficient in carbohydrate to feed our brain. Again, right, this is right from the textbook. A nice diagram to kind of make sure you understand stages of energy metabolism. We have glycolysis, we have um, TCA cycle, also known as Krebs cycle or citric acid cycle. And here's where fat fat gets into energy. We get fat, goes through a number of steps. Remember the long chain fatty acids are cleaved and into uh, two carbon to make acetylnitrile. That's um, it's called um, beta oxidation. The way we break up fat into the acetyl CoA, and it goes into TCA, and then eventually yielding most energy here. We get a little bit of energy out of here, but most of it is when it goes down all the way down here. Uh, many of you have seen this at least in different, in general biology, or if you've taken biochemistry, and hopefully you remember this, and it's not uh, all starting to memorize from things from scratch. We don't need to know it in extreme detail, but know where our macronutrients come in to produce our energy. That's chapter 7. Okay, so here's a series of questions, and you can see, how general or specific they are, but it's good to kind of think about these because you might see some of these very ones on the exam. Okay, which sum of all reactions, we've heard this before, metabolism. which of the following is not a general feature of vitamin, as they say in Britain, or vitamin, which is not. Okay. Yes, vitamins could contain nitrogen. They may be required in large amounts, but it's kind of relative. Supports growth and not maintenance. Okay, so the question is, which is it not? So this is relative, really. Some of them are needed in more than others. We need pretty good doses of vitamin C compared to um, micro. So maybe that's not a great kind of, but they certainly are all organic, meaning they're all carbon based. So watch out for these questions. You gotta kind of think when it says not. You gotta think through. All right, so this is the special feature of vitamin D, that it serves as a hormone, not just a vitamin, a hormone. Hormones are special because they have more interaction, more messaging. They produce somewhere and they act somewhere else. So it's the uh, kind of idea of a hormone. And I mentioned to newborns get this injection of vitamin K because they, for whatever reason, that they don't get that in utero, and it's not present, which is curious. I don't know why that is the case, but they get that. The body derives most of its energy from which of these? So this, we don't directly get energy from vitamins and minerals, although they're very important to be present. Glycerol and fatty acids, we do get it from there, but most is from the combination of glucose from carbohydrate and fatty acids from fats, and not as much from protein. Glycolysis, this is the anaerobic part of our energy metabolism. Um, oh, that's the wrong answer. Glycolysis converts, the right answer is right here, converts glucose to pyruvate, right? Glucose to pyruvate, and stops there. The next step requires oxygen. So this is a wrong answer. Sorry about that. The pathway from pyruvate to acetyl-CoA. So this is the aerobic step, and it is irreversible. So two very important aspects of pyruvate, the 3-carbon, um, uh, from glucose. Glucose produces 2 pyruvates, and then it goes one step more when we're aerobically metabolizing to acetyl-CoA, and it cannot go back this way, and that goes into the TCA cycle. So gluconeogenesis, another important term to know. Gluconeogenesis means making glucose out of a non carbohydrate substrate. Okay, so that could be from amino acids, it could be from glycerol. Complete oxidation of acetyl-CoA. So the first, yeah, well, that's acetyl-CoA goes into the TCA cycle, and then produces electrons and things that go into the electron transport. Body stores energy for future use in what? not proteins, not acetyl-CoA. So triglycerides. Um, so we break down fat into fatty acids. They're moved around, remember, as chylomicrons, and then eventually get to the liver. In the liver, they're pieced back together and stored as triglycerides. It's because they're more stable. Um, okay, there's a, let's see here. Okay, um, I have a question here. How much detail do we need to know glycolysis? And he says so. You don't need to know any of intermediates in glycolysis or TCA. Um, what you do need to remember is what we've said a few times, which is aerobic, which is anaerobic. The important thing of glycolysis, it stops at pyruvate. Um, and if we're not aerobic, then we can't get the rest of the energy out of um, the original glucose TCA cycle. Um, don't need to know intermediates. Know that it's aerobic. Know that we get that's the way we get most of the energy out of carbohydrate going through glycolysis and TCA cycle. Which dietary nutrient most uh, most rapidly reverse in the state of ketosis in a starving person? Okay, so if we're starving, meaning we ran out of, after a certain amount of time, we run out of any stored glucose, maybe run out of stored fat, and then we're making ketone bodies from fat to to serve to some extent the brain. Ketone bodies can save us from brain damage if we're starving, but it's not optimal for the brain. The brain wants glucose really, but these ketone bodies can uh, help for a little while. But as soon as the um, carbohydrate is really what the brain wants, that glucose, and so when we get glucose, then we're reversing ketosis. I know that you might think of, oh, there's the keto diet. The keto diet does um, um, put the body into ketosis for a certain amount of time, but that can't be for long periods of time. It starts to do damage to the body. The pH of the body, of the bloodstream, could begin to become acidic. The brain and red blood cells might not get sufficient nutrition because it wants glucose. Okay, catabolism. Catabolism versus anabolic, or catabolic and anabolic. One is to break down, one is to build up. So you might think of anabolic steroids. What does that do? That enhances building of things, like building muscle. Anabolic is building, catabolic is breaking down. So which is correct here? So we're asking about a breaking down process. So so this question is a little tricky in that it's using the word formation here. And it's asking which is breaking down. So it's forming the breakdown product. So which is the one going from larger to smaller. So this doesn't happen, glucose to glycerol, right? Glycerol is a breakdown product of fatty acid. Um, Pyruvate forming glucose, well, that's reverse. It's really the other way around. And so albumin, you'd have to know that this is a protein. So proteins, this protein forms amino acids. It can be broken down to amino acid. Well, hopefully, if you weren't familiar with albumin, what that is, although that's the major protein in the blood, the buffer in the blood, you can, list as a good strategy in a test. If you're not absolutely sure of the answer, rule out the ones you know is not, and try to get to the best answer.
Professor, can you re-explain, because I'm confused on the formation part, even though it's catabolic.
Okay, so forming, we can also form breakdown products. That's what this is doing. So if you're thinking forming means to build, well, it also could be forming products or breakdown products, and that's what this is saying. So that see, this is wrong because glucose doesn't form in its breaking down doesn't form glycerol. Pyruvate doesn't break down and form glucose. It's really the other way around. If this was glucose formation of pyruvate, that is a catabolic process, breaking down glucose to form pyruvate. That help? So in the answer, this is a large protein, and it can be broken down to form smaller pieces, amino acids. What's a coenzyme? This is asking. So coenzyme. So coenzymes are smaller, a smaller molecule that helps the enzyme. So small active part of an enzyme that binds to an organic reactants. So in this case, it's saying the organic reactants perhaps are going to form something larger. Maybe this is for an anabolic process. So that's a coenzyme, something that helps the process of of forming or breaking down something that enzyme is catalyzing. What accounts for higher energy density of a fatty acid compared to other energy yielding nutrients? So we know that fats in general are 9 kcals per gram, whereas proteins and carbohydrates are 4 kcals per gram. Should remember that in case there's a calculation question. But the reason why the fats are more dense in their kcals is this right here, that they have a higher concentration of bonds because there's lots of carbon hydrogen bonds. And that's why fatty acids are 9 kcals per gram on average, whereas proteins and carbohydrates are 4 kcals per gram on average. Surplus dietary fat. So what happens to that? So kind of straightforward. That's what happens to excess fat. It's excess dietary fat, or also known as lipid. It's stored as fat. Carbohydrate, though, well, carbohydrate is stored as glycogen. It still could be stored, but protein is not stored. It's put into some kind of active molecule, active muscle, into making cementing bones, making antibodies or enzymes. Okay, this is a similar question as before. Fats is 9. Alcohol is 7 kcals per gram, and proteins and carbohydrates are 4 kcals per gram. All right, here's a calculation question that might have one. So in Respondus, there'll be a calculator up there, and it's not real difficult calculations usually. And maybe there'd be one of something like this. So a diet providing 2,200 kcals, which is 40% is fat, 60% is from protein, okay? So that means that what's left? There's 40% left, 40% carbohydrate. How many grams is that? So 40%, so there's two calculations have to do here. Get 40% of this, first of all. 40% of this is what? 808, 880, right? 880, 880. But then you have to divide that by what? By 4. There's 4 kcals per gram. It's asking about grams. So 880 divided by 4 is 220. 220 grams of carbohydrate. So, and again, in MindTap, you had to do some of these calculations, and one of the discussions questions was around something like this: your macromolecule distribution. Gluconeogenesis, where does this mostly take place? It's liver. Among many functions of the liver, it has an incredible amount of things going on in the liver. It stores vitamins. It does this sometimes important process of making glucose from non-carbohydrate. It's the detoxifying organ, incredible organ. So important to keep a liver healthy. And common way to make livers unhealthy is too much alcohol, binge drinking, and that kind of thing is not good for liver. What does it do? It stores fat, and fatty liver is a problem. It changes things in the liver and could change its ability to do all these amazing roles. Visceral fat. Visceral fat. Okay, this is characterizing where fat is located. And that's the abdominal region. This is the unhealthy or less healthy storage area of fat. And it's more common in males. Males have what's seen as, and it's in your book, as like an apple shape when fat is stored, as opposed to a pear shape for females, for whatever reasons. That's what's happening, and the pear shape is a healthier place to store fat. And why? Because this is the abdomen is closer to more important organs like the liver and the pancreas and kidneys. What is possible metabolic reaction in the cell? Okay, so this is saying which is now we could say which is formed, which goes to which. So pyruvate is strictly from carbohydrate. It's the breakdown product of glucose, not urea. Urea is deamination of protein, so we don't see that there. Lactate to pyruvate. Let's hold up on that. Acetyl-CoA to pyruvate. So that's the um, uh, reverse direction. That wouldn't happen. It goes the other way around. Carbon dioxide to glycerol. No, that's not a thing. Fatty acids to glucose. Okay, we see that um, um, fatty acids. So we can use the backbone of fatty acids, but it's this is the better answer. Lactate to pyruvate. So this is one of the extension things. If pyruvate builds up, it um, it turns to lactate if we remain anaerobic. Okay, but we can. This is called the Cori cycle. That the lactate goes to the liver and actually is converted back to pyruvate. So it kind of saves the pyruvate. Powerhouses, you got to remember this. Which one is the powerhouse? Where does all this energy metabolism take place? That's the mitochondria. Which statement is true about body mass index? That's the BMI. The BMI. Okay, just look at those answers there. So it's an indication, a rough indication. So if and this characterizes us as underweight, that's 18.5 and below, and then what's called normal. And these are gross estimates of BMI. BMI is correlating with disease risk. In between there is normal up to about 24, and 24 into about 30 is overweight, and above 30 BMI is obese, and then obesity above 30 has been characterized and divided up into a few categories of obese. Okay, so it just correlates with disease risk. Measure of the, this is important one, measure of the rate at which a nutrient is absorbed and used by the body is the bioavailability. Okay, just a few more here. Getting late. So this is body composition. What's the largest contributor to weight of the body? This shouldn't be difficult. It is water. Something 60 to 70% of our body weight, water. Iron containing, I think this question is not misplaced. This really is for next chapter. Iron containing compound carries oxygen in the bloodstream is hemoglobin. So, okay, this is a vitamin question. Enzyme FAD is formed from what? Which vitamin? So for niacin and riboflavin, the acronyms of the coenzyme look very similar to the word. So this one, riboflavin, is the FAD. The NAD or NADPH is associated with the niacin. Okay, so this one is riboflavin. says which is not among the features of fat-soluble vitamins. So fat-soluble vitamins, it does require, just like all fat substances we're trying to absorb, requires bile that helps it cross into our body, really, across from the GI tract. Found in fatty parts of food. That's true. Yeah, fat-soluble vitamins are. So that's an issue with someone thinking they want to cut out of their eating pattern all fatty foods. That might be a problem. You might become deficient of fat-soluble vitamins. Transported permanently to the liver and adipose. So why would that wouldn't make sense if we permanently transport fat-soluble vitamins to liver and adipose. Then it wouldn't get to tissues and cells and all. So that leaves the last one, and that's the wrong answer. They pose a greater risk of developing toxicity than water-soluble vitamins. Sorry, that arrow is in the wrong place. The answer is D. Okay. Tissue that contains the majority of vitamin A. This is the liver. Okay, this is a role of one of the water-soluble vitamins involved intensively with amino acid metabolism. Okay. So vitamin A, you should remember, that's beta carotene, that's vision, that's skin, that's mucous membranes. Okay, so it's not that. Biotin and riboflavin, very much involved with energy, extracting energy from food. So it is B6 is the one that's involved with, along with B12 also, along with involved in amino acid metabolism. A person who shuns dairy and spends most of her time indoors would likely benefit from a supplement of vitamin D. Right, so we get a good part of our vitamin D from the precursor cholesterol in our skin, converts several steps to vitamin D. So we haven't said much about what the symptoms of deficiencies are. Here's one. As far as we know, vitamin A does not play a role in which of the following processes. So vitamin A has a few different roles. It's not the blood clotting. So vitamin A has these three roles. Teeth and bones, it's involved there, but its major one is in vision, synthesizing those involved with the cones and rods in us visualizing, especially night vision, and mucous membranes. So again, studying vitamins, just think of a vitamin, close your eyes, and think of what comes to mind. If you need to look at something else to remember, but that's the way that we remember things, right? Don't just read things over and over. Close your eyes and try to remember what you think of. Okay, deficiency here, resulting from folate deficiency. Which type of neural tube defect? Okay, so this is the folate. That's why you might know expecting women, pregnant women are always making sure that they get sufficient folate. Folate's extremely important for developing fetus in making sure its bone formation is bone and nerves are developing properly. Spina bifida is what the disease is called when neurotubular function is defective. Which vitamins is critical in energy metabolism by virtue of acetyl-CoA? Okay, this is one of the least known B vitamins, right? So it's got to be this pantothenic acid. So pantothenic acid, try to remember pantothenic acid associated with acetyl-CoA. Acetyl-CoA, really important. That's the breakdown. That's the 2-carbon molecule in energy metabolism. Pyruvate goes to acetyl-CoA, and then it goes into the TCA cycle. So pantothenic acid is critical for going from pyruvate to acetyl-CoA, and that's energy. All right. So my alma mater is the University of Florida, and if you're a Florida Gator, you know this story. Gatorade originated by Dr. Cade, who was a researcher and urologist at the University of Florida, who came up with the formulation for Gatorade. And all these are true. He developed the proper ratio of electrolytes that made water absorb faster, along with electrolytes. He formulated it from the sweat of the Florida football team over the course of years. That was in the 60s, and Gatorade made a lot of money for the University of Florida. It's been the product, the brand has been sold a few times already. I don't know why that question's there. That's for the next chapter. Which of the following is not known to be involved in maintaining bones and teeth? Well, all of them except E. So vitamin E, remember, is the antioxidant. Antioxidant involved with quenching or stopping the risk of free radicals. In our biochemistry, there's in all our mechanisms and processes and reactions, there are free radicals that are formed. All our reactions are not perfect. Sometimes reactive species leave the reaction and could be hazardous, but that's why we need vitamin D around. Sorry, this shouldn't be this is for next chapter 2, electrolyte and water balances, osmosis. Okay, bioavailability. There certainly will be a question or two about bioavailability. We saw one earlier. That's the absorbed and used by the body. Absorbed and used by the body. That's what is meant about bioavailability. You can absorb perhaps absorb something, and if it's not properly made into the vitamin form, then it's not bioavailability. We might not have another vitamin or coenzyme that's necessary to make that vitamin into its useful form. So it's both absorbed and subsequently used by the body. Okay, this is kind of a repeat. It's vitamin D is the one that functions as a hormone. Not for this chapter, sorry. Okay, which of the following explains why B vitamin deficiencies lead to lack of energy? Okay, so this is why you might hear that someone saying, why don't you get a B vitamin supplement if you're feeling drowsy and feeling lack of energy, It could be that you're deficient. Where do we get our B vitamins from? Mainly, mainly from vegetables, and from plant sources. Except for B12 comes from more meat food sources. Okay, because coenzymes needed for energy are produced in insufficient amount. We don't make enough. In fact, if it's a vitamin, we don't make enough of them in the body. So we need it through our eating pattern. Okay, vitamin E is a antioxidant. Okay, so what was not reviewed here, and you should review, is are the major um, the symptoms of some of the diseases possible from deficiencies. The main ones, think of pellagra, um, and scurvy. We mentioned vitamin C, um, pellagra, thiamine, and uh, so not many that we need to remember. Um, so interestingly, scurvy was said to be one of the first vitamins to be discovered, and that was from bleeding gums from sailors that came back from long excursions and ran out of citrus and wasn't getting enough vitamin C. Eventually, it was connected with vitamin C, scurvy. That is the folate or folic acid with spina bifida of newborns. Um, yeah, so E, we said antioxidant. A is to do with vision, night blindness, um, skin related. You might know that sometimes vitamin A or beta-carotene formulations given for skin conditions to try to improve them. Yes, so those examples there. Those are questions similar to what, or maybe some of them will be actually be on the test. And the short essays showed a few of them, but in the beginning, now just think of what we could we ask. Also in those study guides, are good to go over, because that's where questions um, basically are coming from that sort of thinking. Those are the highlights from the chapters. Okay, so this what's showing here is a really great burger. I have I don't eat a lot of red meat, but when I'm in New York City, there's a great burger place that has great sweet potato fries and regular fries. It's called the Burger Joint on 56th Street between 7th and 5th Avenues. Burger Joint. If you're looking for a good burger and interesting atmosphere. It's in a fancy hotel. You have to walk behind this curtain to get to it. It's kind of, they don't need to advertise. They're always so busy. The Burger Joint. Any questions, comments? Anybody having trouble with any of the processes, mind tap or um, okay, well, don't hesitate to reach out. Any questions, as people normally do? Yes, go ahead.
Yes, hi, sir.
Hi.
So, sir, I need to ask that in the Diet and Wellness Plus, there was in the last chapter weight management and the obesity one. Do we need to send any report to you?
No,
We
no,
just need to answer the questions.
yes, yeah.
So
Maybe, now I kind of remember reading, and maybe I didn't answer your email, but no,
yeah,
there's no.
it's fine.
Sorry, I'm
It's
sorry.
okay. Don't be sorry.
There's
It's
no,
okay.
there's no extra report. It's only those questions. So
That's it. Okay.
yeah, you're looking at the report is what the what MindTab does. It generates a report that we look at, and then the
Yeah.
follow-up questions.
So I don't need to, I just pick my own days, which is suitable for me to write the diet plan, and then I answered the questions.
Right.
That's fine. I don't need to send any report to you, right?
No.
Thank you so much, sir, for giving me extension. I was having a very bad COVID at least last month, and I was in a dehydration stage. But thanks for